Okay, so now we get to the next part where we're going to review our work from the other day about addition and subtraction of polynomials, and then get into a little bit about multiplication and division of polynomials, which will set up our factoring that we do next week. So, anyway, polynomials, addition and subtraction. Let's get to work on this. Since we did some work on this the other day, this is just a quick reminder. Basically, adding and subtracting polynomials is taking a complete chaotic mess like laundry and organizing it in such a way that everything is where it belongs, and you can access whatever information or clothing in this particular case you might need. And an example of where it can be very beneficial and is just like is when you keep money in your wallet. You really should have that money so that they're ordered, like say hundreds, then 50s, then 20s, then 10s, then 5s, then singles. What you don't want to do is have them mixed all over the place, because you might accidentally give the wrong bill and overpay for something. Okay, if it was underpaid, I'm sure the other person would bring it to your attention. Okay, let's have you try numbers 1 and 2. As we did this the other day, I think that you should have no problem, and I don't need to teach you first. So let's try 1 and 2. Yes. Okay, I know you're doing stop and start. My wife just got home from dog training, so she just kind of asked me a question there. Number 1, I have only one term that has a 4m squared on it, so I put that term together. Then I have, because we're adding, we don't change any signs, right? We have 3m and negative 5m, which is negative 2m. Plus 2m is no m's. Now, could you write 0 m's in there? You could, but it would be kind of tacky, kind of like wearing white after Labor Day, okay? Or you could just leave it out. So leaving it out is the way that we would normally go. But 0 m's means 0 times m, which means nothing. So that's why it is technically equal. And then negative 7 and negative 9 make negative 16. For number 2, now this is very different. In number 1, we have an addition between the two groups, or polynomials. In number 2, we have a subtraction between the same exact two groups, or polynomials. So I'm going to distribute the negative sign. I think of it as a negative 1. I'm going to distribute the negative 1 to all three terms. Or I could look at it as this is a negation symbol, and this is the way I like to look at it. I'm going to negate everything in the group that follows. So I have to negate the negative 5m, the negative 9, and the plus 2m. So that gives me, now because the 3m plus 4m squared minus 7 is before the negate, the negate doesn't apply to it. The negate only applies to what follows it. So the negative 5m becomes plus 5m, the negative 9 becomes plus 9, and the 2m becomes negative 2m. And now, as before, I combine like terms. 4m squared plus 8m minus 2m is 6m, and negative 7 and positive 9 makes positive 2. Note, same numbers to start with, addition and subtraction give very different answers. Okay, try number 3. Oh, well, make sure you get that answer for number 3. I don't know why the answer appeared, but try 3 and then 4. Make sure you get that answer for 3 and then number 4. Okay, so on the first one, I have 8x squared and I have 4x squared, so altogether that's 12x squared. And then I don't have anything to combine with the negative 3x, so it's just negative 3x. And I have nothing to combine with the negative 1, so it's just negative 1. For number 4, I first have to distribute that negative sign. I always got to do that first. Combining like terms is really adding, so, and distributing a negative is multiplying, distributing is always multiplying, negating is multiplying. So that's why you have to do it first. So first I negate the 4x squared and get negative 4x squared. The negative 3x, you get positive 3x. So 8x squared and negative 4x squared is 4x squared. And then it's a positive 3x and a negative 1. Again, very different answers. Okay, let's try this one. Stop and start. Okay, so for the first 3 days, which are Monday, Tuesday, and Wednesday, each of these amounts is mode. So we're going to add them up, and that means we're going to get 2x squared plus 5x minus 3, plus the 4x minus 7 for Tuesday, and Wednesday is 3x squared plus 10. So let's go get all my x squareds together. 2x squared and 3x squared make 5x squared. Now let's get all my x's together. 5x's and 4x's make 9x's. And that's all my x's. Now the numbers, -3 and -7 make -10, and +10 is nothing. So I could write +0, but I don't usually do that. That, again, is considered tacky. Now, what I do want you to realize on this is it's very, it simplifies things to write in what we call standard polynomial form, which is the highest exponent, then next highest, and next highest until we get to a constant. So 2x squared plus 5x minus 3, and later on 3x squared plus 10, in between 4x minus 7. And what it does is it gives a certain rhythm to as you're doing the problem. Like you kind of expect to find the x squareds as each of these terms begin. And if it's not there, it kind of catches your attention. Like, why is it not there? Oh, wait, that term didn't have an x squared. Okay? So it makes things simpler to deal with. Okay? Final answer, 5x squared plus 9x. Now let's do letter B, which says if Bob mowed 14x squared plus 12x minus 3 yards total for the entire week, how many yards did he mow during the rest of the week? So the rest of the week is all the days except Monday, Tuesday, Wednesday. So he has to subtract the answer to part A from what you're given in part B. Go ahead. Okay, so 14x squared plus 12x minus 3 minus, and then I'm minusing or subtracting the entire thing, which is 5x squared plus 9x. So I have to negate everything in that package that follows the negation or subtraction symbol. So that's -5x squared minus 9x. Now I combine my like terms. 14x squared minus 5x squared is 9x squared. 12x minus 9x is 3x. And there's nothing to combine with the -3. So that's the correct answer. Okay, so that's a quick review of adding and subtracting polynomials, work that we did in the previous lesson, which I think was lesson 9. And hopefully you're feeling a certain level of comfort with that. Now we get into multiplying and dividing polynomials. So when you learned this in high school, a lot of teachers taught it as FOIL, which stood for first, outers, inners, last. And if I tried to explain to you just how much I hate that acronym, to me, that's so much. I'm going to go on a rant here for a minute. I'll try to keep it short. That to me represents so much of what's wrong with math teaching in America today, maybe the world, I don't know. What I hate so much about it is that it reduces math to gimmicks, to a particular skill with no continuity of concepts, no broader understanding. No wonder why students hate mathematics, and no wonder why it makes no sense. You know, when I was a kid, believe it or not, I know this is going to be really, really difficult for you to accept, but when I was a child, we didn't have cell phones. No, we didn't even have phones that were capable of like keeping phone numbers in memory. You, believe it or not, you actually had to remember all your friends' phone numbers. Can you believe that? And now, so if you had only one friend and you only had one phone number to remember, and before you feel bad for the person with one friend, it might have been like the greatest friend you could ever want to have, which is really cool. If you only had to remember the one phone number, it was simple. Like my best friend growing up was Bobby Von Aiken, and I don't remember Bobby's phone number, but I do remember my last best friend before all of the cell phones became a big deal. He was a man named Ken Turco. He was a fantastic, amazing man, probably the best man I will ever know. And his phone number was 631-728-3797. Now, I remember that because I dialed it enough, but I can look on my wall here, and other than the area code, which is missing, I have he used to be a fly fishing and light tackle guide on a boat, and he had a sign at the dock, and I have the sign hanging on my wall. So I know that I'm right. I just peeked at the phone number to make sure I was right. And I peeked after I said I remembered it. So in math, if you have only one or two skills to know, easy to remember. But imagine the person who has like 10 friends. Isn't it harder for that person to remember the phone numbers of 10 friends than the person who only has one friend? Well, what if you have 50 friends? What if you have 100 or 200 friends and all of those phone numbers? They're really difficult to remember. Now, in mathematics, in a regular school year, you get 180 lessons. And, well, let's say some days for testing and re-going over. So you're going to get 150 lessons. That's 150 phone number type things you have to remember if I teach it as FOIL, first outers, inners, last. And that's assuming only one of these a day. So instead, I like to just keep things familiar with concepts that we already know. So for instance, you guys know how to distribute. So what I'm going to do here is, instead of calling this FOIL, I'm going to call it double distribute. So I'm distributing across the x plus 10. What am I distributing? I'm distributing both the x and the negative 4. So first I distribute the x, and that's the two red hoops, okay? So x times x is x squared, and x times 10 is 10x. Now I've distributed the x. It's time to distribute the negative 4. So now I distribute the negative 4. I completely ignore the x because I already did that. Negative 4 times x is negative 4x, and negative 4 times 10 is negative 40. Now, the red distributions lead to the things, or the monomials that are underlined by red, and the green distribution, those underlined by green. When you do this, it will almost always be the case that when you add the middle terms, they can be simplified. So the x squared, there's no other x squared term, so it stays together. The negative 40, nothing to combine with negative 40. But 10x is positive, and 4x is negative, remember to peek in front, is positive 6x's. So altogether I get x squared plus 6x minus 40. Okay, you try number 2. Go ahead. As always, stop and start. Okay, so x times x is x squared. X times negative 9 is negative 9x. Oh, that was just to highlight that you can combine the 10x and negative 4x. So I distributed the x to the x and got x squared. X times negative 9 is negative 9x. Now I'm distributing the 5. 5 times x is 5x. 5 times negative 9 is negative 45. I can combine in the middle there the negative 9x and the 5x. That gets me x squared. That stays the same. The negative 45 stays the same. Negative 9x plus 5x is negative 4x. Okay, let's try number 3. First, we call this double distribute. And I like the concept because you know how to distribute already. So we're going to distribute the 2x to both terms. Then we're going to distribute the negative 4 to both terms. And then we're going to look to combine the middle terms. Okay, so 2x times 3x is 6x squared. 2x times 6 is 12x. So those are the first two terms. Then negative 4 times 3x is negative 12x. Negative 4 times 6 is negative 24. The two middle terms are combinable, and check it out, they add up to no x's. So the final answer is 6x squared minus 24. As I mentioned in the previous video, if you happen to put 0 x's in the middle, it's not like you would be wrong. And for something we do later called factoring in the beginning, it might actually help you understand the factoring a little bit better. But I'll tell you what it doesn't do. It's considered tacky. So we don't normally write it. We just leave it 6x squared minus 24. Okay, number 4, distribute the 5x, then distribute the negative 7y, then combine like terms as best you possibly can. Go ahead. Okay, so you distribute, and 5x times negative x is negative 5x squared. 5x times 8y is 40xy. Now I'm going to distribute the negative 7y times x, which is plus 7xy. And last but not least, negative 7y times 8y is negative 56y squared. The middle terms are combinable. I get negative 5x squared, which is the only x squared term, so it's by itself. In the middle, I get 47xy's. Now, what's an xy? I don't know. But I do know it's different than an x squared, and I know it's different than a y squared, and I know I got 47 of them, so I leave it there. And then minus 56y squared. Okay? All right. Let's see you try this one piece by piece. Let's have you do the first two. We'll go over those, and then you can do the last two. So try 19 and 21. Go ahead. Okay, so, and again, I'm always assuming you're doing stop and start here. 9x times x is 9x squared. 9x times negative 6 is negative 54x. Now I'm going to do negative 4 times x, which is negative 4x, and negative 4 times negative 6 is plus 24. The middle terms are combinable to negative 58x. Number 21. First we distribute the negative 5x, and I get negative 5x squared minus 25x. Then I distribute the 6, and I get, and that 6 is a positive, 6x, and positive 6 times positive 5 is 30. Combining middle terms, I get negative 19x in the middle. So negative 5x squared minus 19x plus 30. Okay, little stop and start on 23 and 25. Go ahead. All right, so distributing the x squared here, and this is interesting because this is the first time that we've had an x squared that we're distributing. So got to be careful about combining like terms here. X squared times x is x cubed. X squared times 4 is 4x squared. Now I distribute the negative 8 times x is negative 8x's, and negative 8 times 4 is negative 32. I can't combine any of those terms, so I am done. Next one, x squared times x is x cubed. X squared times negative 3 is negative 3x squared. 10x times x is 10x squared. And 10x times negative 3 is negative 30x. And I want you to notice again that there are no, there are like terms to combine. Sorry. In the middle, altogether, I have 7x squared. So I have x cubed plus 7x squared minus 30x. Okay? All right. Now, we have double distribute, but it could also be triple distribute. It doesn't make a difference. In the problem on the left, we're going to distribute both the x and the negative 5 to all three terms, the x squared plus the 7x minus 3. Okay, try just that one, and then we'll go over the answers. Okay, so distributing the 5, and I'm going to get I'm sorry, I said the 5, I meant the x. Distributing the x, I get x cubed plus 7x squared minus 3x. Now distributing, and it's not a 5, it's a negative 5. Gives me negative 5x squared minus 35x, and then plus 15, right? Because negative 5 times negative 3 is 15. And now you're going to get a couple of combinables. The x cubed is by itself, but look, I got a 7x squared and a negative 5x squared. I can group them together. And a negative 3x and a negative 35x, which can be grouped together. So I get x cubed plus 7x squared, right? I'm sorry, plus 2x squared, which is 7x squared minus 5x squared. And then negative 3x and negative 35x is negative 38x and plus 15. Now, on the right-hand side, we're going to distribute both the 2x first to all three terms, and then the negative 7. Go ahead, try that. Okay, so I distribute the 2x, and 2x times 4x squared is 8x cubed. 2x times negative 5x is negative 10x squared, and 2x times negative 9 is negative 18x. Then I do negative 7 times 4x squared, which is negative 28x squared, negative 7 times negative 5x, which is 35x, and negative 7 times negative 9, which is 63. When I combine my x squareds together, negative 10 and negative 28 make negative 38x squareds. And then when I combine my x's, negative 18x and 35x makes 17x. And then, of course, the plus 63 and the 8x cubed have nothing to be combined with them. So that is double distribute, triple distribute. As you can imagine, we can easily do quadruple or quintuple distribute. It makes no difference. It's the same concept applied repeatedly. Next up, dividing. Now, most students don't like dividing fifth grade division, where long division. Most students do not like that. Most college students do not like that. So we're going to cover this, and it's not going to be your favorite thing. But it's important to know that it works the same way, and maybe that'll shed a little light on what you did way back when you were in elementary school. So I wrote this problem on the right-hand side. I did 17 goes into 291. 17 will go into 29 once. That's why we put the 1 over the 9. And 17, and what we do here is 17 times 1, and that gives us 17. So I'm always going to multiply by how many times it goes into it, whatever the divisor is. So 17 times 1 is 17. That's a 12. Bring down the 1. Remember, we always bring that down. And then 17 goes into 121 7 times, and that's 119. And there's 2 parts left over. And there's a few ways we can handle this, but one way that we handled it was to just write it as a fraction. So it goes in 17 whole times and 2 parts left over out of 17. So we called it 17 and 2/7. Okay, so let's have you now take a look at what I did all the way on the left here. X plus 7 divided into x squared plus 12x plus 35. Now, just like over here when I was trying to figure out how many times 17 went into something, I kind of looked at 17 in my mind. I'm kind of not paying attention to the whole 17, but I'm saying, well, that's about 20. So let's see how that works. In here, I'm going to focus on the x's. So x times what would get me x squared? Well, x times x. So the first part of the answer has to be the x. And when I distribute, just like over here, I did the 17 times 1 and made 17. Over here, I'm going to do the x plus 7 times x, and I get x squared plus 7x. Now, subtract 12x minus 7x is 5x, and then bring down to 35. Now, x times 5 would give you 5x, so I put a plus 5 up top there, and then I distribute that 5 to the x plus 7, and I get 5x plus 35. And when I subtract, I get 0. So that means that x plus 7 goes into x squared plus 12x plus 35, and even x plus 5 times. It goes in evenly. Which, if we turned it around, we could say x plus 7 times x plus 5 is equal to x squared plus 12x plus 35. And we're going to do a lot of questions like that next week in our head as we begin to really understand factoring. So now on the upper right one that says x squared minus 8x minus 9 divided by, and that should say x plus 1, okay? Just make sure you realize that's x plus 1. Okay, so what I would like you to do is set it up and try it. And I've already written out the answer, and each time I click on one of these rectangles, it will disappear, and the answer will be revealed step by step to you. Okay, I assume you did stop and start. So the first part says x plus 1 goes into x squared minus 8x minus 9. Yes, you see the answer because I couldn't delay that until the end. So x goes into x squared exactly x times. And when I distribute that x up top, right there, by the x plus 1, I get x squared plus x. When I subtract that, and this is a scribble out up here, so it's just x minus 9. When I subtract that, I'm left with 9x, right? Negative 8x minus an x makes negative 9x. I subtract there, just like over here, when I did 29 minus 17, I got 12. And then I bring down the negative 9. And then x plus 1 times a negative 9 gives me negative 9x minus 9. So there's no leftover, so that's the correct answer, x minus 9. Okay. There's this stuff. There's just so much being written down that sometimes students can get lost in the minutia. Not that the process looks that difficult, but there's just so many steps within each process. Okay, so let's do the next one, which is much longer looking. And it's really important on this first one that I set it up for you because there's a trick in here. I want you to notice that there is no cubed terms. It goes from 3x to the fourth straight down to minus 7x squared. And there's no x cubed term in the middle. Whenever that happens, you have to write it in with 0x cubes, or anything that you skip has to be put in there with the 0. So I'm going to pause for a second. I'm going to let you try to understand all the work that I did, and then I'm going to go back and go over that work with you. So you do stop and start, and then I'll come back with the work and the explanation for all of the work that's there. Okay, so what do we have going on here? Well, first, x plus 2 is going to divide into 3x to the fourth. So to do that, I need a 3 for the coefficient part, right? 1 goes into 3 times. And then x goes into x to the fourth, x cubed times. And let's distribute back to check ourselves. 3x cubed times x is 3x to the fourth. That is a true statement, right? Because there's really a little 1 on the x here. And then 3x cubed times 2 is 6x cubed. And then I subtract. So 3x to the fourth minus 3x to the fourth is nothing. 0x cubed minus 6x cubed is negative 6x cubed. Bring down the negative 7x squared. Okay, then I'm going to have to multiply by negative 6x squared. And that will give me negative 6x cubed minus 12x squared. The negative 6x cubes will cancel each other out when you subtract. Negative 7x squared minus negative 12x squared is 5x squared. Bring down the plus 5x. Now I'm going to have to multiply by 5x, because 5x times x is 5x squared, and 5x times 2 is 10x. Subtracting negative 5x, bringing it down, negative 7. So that gives me negative 5x minus 7. Clearly, I need to multiply x plus 2 by negative 5 to go into that. That gives me negative 5x minus 10. And when I subtract, negative 5x's cancel out, but negative 7 minus negative 10 is 3. So then I write as my final step the last piece as a remainder. 3 parts remain out of the x plus 2 I divided it into. So that is how we do a subtraction question from beginning to end. A few different concepts. First off, if they don't have an x cubed term or an x to the whatever term, you have to put a 0, as long as it's in between. Like there's no x cubed between an x to the fourth and an x squared, you have to put in 0 x cubes. If there's no x between, say, the x squared and the number, you have to put in a 0x. If there's no number at the end, you have to put in a plus 0. So remember that, and then also remember to just go methodically step by step, each step of the way. So I'm going to give you a moment to work on this one. This is our last question for the day before we do the happy recap. And as you go into it, I will go over the answer with you in a few seconds of my time, a couple of minutes your time. Okay, so here's my setup. 2x minus 3 goes into 8x to the fourth, and here's the trick part, plus 0x cubes, plus 8x squareds, plus 0x's, minus 8. So let's go through this step by step. First, 2x times 4x cubed will give you the 8x to the fourth, and the 4x cubed times negative 3 will give you negative 12x cubes. Subtracting, I get 12x cubed plus 8x squared. Okay. Then I say, well, how many times does 2x go into 12x cubed? And it goes in 6x squared, right? 2 goes into 12 6 times, and x goes into x cubed, x squared times. So I subtract that, and I get, don't forget, I also have to bring down the 8x squared, sorry. Distributing back, 6x squared times 2x minus 3. 6x squared times 2x is 12x cubed. And 6x squared times negative 3 is negative 18x squared. Okay. Now I need to subtract those. And that'll give me 26x squareds. And bring down the plus 0x. To go from 2x into 26x squared, I got to do plus 13x. When I do that, I get 26x squared minus 39x. Subtracting 0x's, well, 26x squared minus 26x squared is nothing, so that cancels out. I kind of glossed over that. And then 0x's minus a negative 39x leaves you with 39x. Bring down the minus 8. Then what we're going to do is say how many times does 2x go into 39x? And that would be 19 times, because 2x times 19 is 38x, and then 19 times negative 3 is minus 57. And when I'm done subtracting, I'm left with x plus 49. And I'm out of opportunities to go any further. I've done the last term. So the final answer is 4x cubed plus 6x squared plus 13x plus 19, and then x plus 49 over 2x minus 3. Okay. Now, any further questions on this? If there were, address them to me in an email. Happy recap. When it comes to combining like terms, it is like laundry. Gather up your like terms, combine them, and if they're not the same kind of terms, keep them separate. So in other words, when you put your clothes or take your clothes out of the dryer, you can put all your hoodies with your hoodies and your jeans with your jeans and your t-shirts with your t-shirts. But don't go mixing your hoodies with your jeans, right? We want to keep them separate in their neat piles so we know where to put them back in the closet. Now, as far as if you get a problem where you have numbers in front of the parentheses with combining like terms, you have to distribute first. If it's subtraction, make sure you distribute the negative sign, which is a -1, and you are negating everything. For number 7, double distribute. Make sure you look to combine like terms. When you're multiplying a pair of binomials, you're going to double distribute, and then look for those terms in the middle that you can combine. And number 8, it's dividing, and it's like elementary school long division, but you have to include every exponent. So you have to put in like 0x cubes or 0x's if you should skip any of those. Okay, so there's the last of our lesson for today, multiplying and dividing polynomials. And of course, over the next 3 weeks to a month, we'll do 1 or 2 of those every day in our pregame stretch.